In this video we will look at how we can solve a trigonometric equation using the calculator. So let's start with a straightforward example, which will be something like solve sine x equals 0.25, and we will go from 0 to 360. So notice our domain is in degrees, so the answers that we will write down, the solutions that we give, will also be in degrees. So first thing is, I would sketch it anyway. We know what the sine graph looks like. So there's a sketch of the sine graph. Very small, very straightforward, and that would be 360 degrees right there. So really what we're looking for, because we're using the calculator, we need to have some evidence somewhere. Now what we can do is simply tap in the equation. So y equals sine of x, close brackets if you wish, and then do a little check, because the last time we played with this we may have been in radians. Yes, we are. And no domain is in degrees. So I've just checked the mode to make sure everything's okay. And then we're going to do y equals sine x, and we're going to do zoom 7, the trigonometric zoom. And there you have it. If you're like me, you want to make it a little bit tidier if you like. So I am now going to use the window. I'm going to go from 0 to 360. The scale can be in 90s, and I'll go from -1 to 1. Now when I graph it, I get the little sketch that I've got on my paper. Now we're trying to solve sine x equals 0.25. Well, what we've just done is we've graphed y equals sine x. And so what we're saying, if we compare y equals sine x with sine x equals 0.25, then the next thing that we can think of is those two must be equal. So the simplest thing right now is to plot y equals 0.25. And y equals 0.25 can be put into y2, and then when I graph that, it gives us a straight line, which is what we'd expect. Okay, going across at y equals 0.25, and that's it. The rest we've seen before. All we need to do now is second calc. Now this time what we're going to look for is not for zeros, we're looking for the intersection point. So if I go 5, now again you've got to go with first curve, second curve this time. And what I'm doing is just taking the cursor around the curve so it's somewhere near the point of intersection. So first curve, bring it somewhere near the point of intersection and press enter. It jumps to the second curve, which in this case is a straight line. Enter, and then the guess is an enter again. So what we end up with, according to the calculator, is that x is 14.477 ... So x approximately, in fact no, I won't put approximately, is equal to 14.5 degrees if we round it to 3 significant figures. Now obviously we're looking at all solutions between 0 and 360, and you can see from the calculator that there's another one that we haven't got. So go second calc again to number 5, move it across so that it's somewhere near. First curve, enter, jumps to the second curve, enter, enter again, and the second solution is 165.522 blah blah. x is approximately 165 and up to 366, and that's it. That's that one done. We can make them a little easier or harder, it doesn't really matter. We can use sines, cosines, tangents, again, when it doesn't matter. The idea is the same each time. So what I'll do is I'll just delete this one and we'll have a look at another example. Alright, I'll also clear all this off here. Okay, and this time we'll do one in radians. So here's an example. Here we go. Something like, I don't know, solve, I don't know, sine 2x plus 1 equals x. And this time what we'll do is we'll go from, let's go from 0 for x, let's go from 0 to pi and see what happens. Notice by doing pi I'm in radians, so I need to change my mode into radians. Okay, and you can clear that. Y equals. Now in this case basically it's the same every time. I've got a left hand side and a right hand side. If I put that one in as y1 and I put this one in as y2, what we're looking for is where does y1 equal y2. Okay, so all I'm going to do now is I am going to graph two different graphs. I'm going to graph y1 equals, now I'll go over to the calculator, y1 equals sine 2x close bracket plus 1, move down 1, and also sine x. So what I've done is I've put both of the halves, if you like, of this equation. I've put one into y1 and one into y2. When we graph this now, let's see what happens. Okay. There we go. Wonderful. And there's the other one. Looks like piano keys. Lovely. Makes a nice pattern, but it doesn't help us at all. What is the... Correct? Yep. We saw this before when we did the sunrise and sunset. We did the hours of daylight at Bangkok. What we've got to be careful of is, yes, we are in radians, but our window is still in degrees. So what we're going to do is we're going to go from 0. Now, the domain that we're given in the question is 0 to pi. So let's go from 0 to pi. So I'm actually going to put pi as well, not 3.14. Ready? Second, pi. I can't go a scale of 90 because that makes no sense at all, but I could do pi over 2. I could do pi over 4. It really doesn't matter. Let me do pi over 2. So pi divide 2. And as you press enter, you can see it changes it into a decimal. Okay? Now, sine 2x plus 1. Well, let's just graph it. Let's just graph it because there is going to be another problem, but we'll have a look at it first. Okay? There's sine 2x plus 1. There's sine x. Okay. Now, can you see the problem? y1, the left-hand side of our equation, is y equals sine 2x plus 1, which means that it's had a vertical translation on unit. So ideally, we need to change that window again. So let's change the window, leave the x's okay. I'm going to go from 0 to 2 and graph that. This time, look, it fits nicely in the window. And then here comes part of the sine graph, and we're there. So for instance, what we're looking at again, for evidence, we need to be drawing a reasonable sketch of that. Okay. Notice I'm putting the curve in first. Often it helps rather than putting the axes in. And now it looks like it's about there somewhere. This would be pi over 2. This would be pi. And I'm just going to make that go up and over like that. Alright. You'll see that this is 1 here. And this is 2. Make it a little bit longer. This is 2 here. So what we have is the top, if you like, the maximum of that is there, and that's one across there. So what we're doing, we're looking at the places between 0 and pi, where the left side equals the right side. In other words, where does y1 equal y2? Well, there's one place, and there's the other. Okay, so let's just have a look at that. Going back to our calculator, we can simply go second calc. We're looking for the intersection point. Ooh, close. I'm going to go to the first curve and enter it. I'm going to go to the second curve and enter it, and then guess it. And this is 1.570 blah blah blah. Okay, so x equals 1.577. X is equal to 1.5707 blah blah blah. Now, you may have recognized from your sketch that you've drawn that this could be written as 1.57 to 3 significant figures, or you might recognize that that is actually pi over 2. Okay, let's just check that. I'm just going to go off this screen, and I'm going to do second pi divide 2, and there's that 1.5707, just to prove that it is pi over 2. Okay, the y equals is still the same, and the graph is still there as well. So let's look at the other intersection point. So I need to move left, so I beg your pardon, right, somewhere down there. First curve, enter, jump to second curve, enter, take a guess, and you've got x equals 2.786 3 blah blah blah. So x is 2.793 figures. Okay. That might, it's an obvious one in terms of radians and things, so we can leave it just like that, no problem at all. And that's it really.